Okay, so today we are gonna see how the uh, first rudimental prototype of the ground station written in C Sharp works, only in simulation mode for now. And to perform the simulation, we will use the ArduPilot Mission Planner. So at first we open ArduPilot Mission Planner and then we go in simulation mode. You must have downloaded the multi-rotor model, and we will instantiate one multi-rotor, one quadcopter. But instead of using this multi-rotor, in order to not go into problems for what concerns the drone that doesn't follow orders, it is easier to instantiate the drone by going into copter swarm single link, and instead of using many drones you just instantiate one. You choose stable version and then it should pop up. Okay, so it is going to localize in a bit. Okay, so here is our drone, and now I will show you how uh, to start the ground station Windows Form application. So you must have a folder that looks like this. Inside the ground station you find all the code. Well, actually it should look like this. Here there is a reference. This is the library, the DroneLink library compiled. And then you have a folder which is ground station. Inside you have the code, the packages needed for the code to run properly. And here there is the ground station solution. This is the way you open the overall ground station. Okay, by clicking here, you open the overall solution and you will see it is divided into many C# files that are divided into field of competence. And here there is the overall project. If you right click here, you can see that you can compile from here. So this is what you will do in your own PC. I won't compile since I have already done it before. But and also another important thing is here that since in here we will have many references to uh, the DroneLink library. For instance, here drone.connect, which is a command, method of the class drone, um, which is in the library. If we do not make any reference to the library, it won't work. So in order to do this, you right click, you go in add reference and then browse, and you click on the DLL file and you click add. Now, when you will uh, when this line of code is executed, it will automatically know that the connect function, it will look for the connect function inside the library, and so it will work. In order to make it work, you start by clicking this button here, and then it executes. You will see that this is the main interface. Here there are many basic commands. Here the modes, the simulation mode connects to the ArduPilot simulator, whereas the production mode goes through the, for instance, I click here, uh, through the comms, and um, by going through the comms, it will send signals through radio communication to the drone that I do not have here. But the important thing of this form is the fact that The drone works in the same way in both simulation and production. If there is an error during production, so during the flight with the real drone, it's because the hardware is broken, not because the um, the commands have different results on the real and the simulated one. So it is a real modular structure. You can do software in the loop during simulation and hardware in the loop in production mode without having any sort of gap related to functions and commands that are sent. Here you can select outdoor or indoor, which is a great functionality. So outdoor is when you are outdoor, whereas indoor when you fly in closed spaces in which you cannot have GPS signals, so it has to rely on its own reconstruction of the position that happens through very complex math that we don't have to do because it is already in the drone's firmware, and so it is not required by us, but the most important thing you have to remember is that when we fly outdoor, we have the GPS and many other parameters that we cannot have indoor. And so there are two different ways of flying. For instance, when you want to set a fence, when you are outdoor, uh, the fence check is already provided in a given sense um, by the mechanisms that are inside ArduPilot, whereas when you are indoor, you have to provide yourself a specific check for X, Y, and Z position in order to constrain the drone to fly in a given fence, let's say. So for now, we will go in outdoor mode, in simulation mode, and we connect and we see it doesn't give any error. And if we go in this terminal, there is a new connection on serial 2 for what concerns ArduPilot Mission Planner. But we don't see anything here. There is this image that you can change how you want. But this is because we don't have any access to the telemetry. So as soon as we enable the telemetry, the data starts flooding in. So you give a little time to stabilize, and when they're stabilized, the image pops off, and then this this map appears also here as it is in the ArduPilot Mission Planner. This means that when you will have the real drone, you will see how you will see where the real drone is without having the need to use ArduPilot. Then some other things you can do is that as you have the outdoor, when you use the indoor, you can pop up like this the indoor map by enabling it. Here we see that it is in 00 because when it begins, it sets is home at where it is located. Here we see it is in the drone lab, but if it was inside a facility, you would have this and you would not have the signal here. It would be probably all blue without having an exact location. Then here, if we zoom in, we see a black line, which is where the drone is pointing with its speed, whereas under here there is a red line you will see in action later, which is where the drone heading is facing. So one is where the drone is going and one is where the drone is looking at. So it is useful, for instance, when you use the camera, you know where the drone is looking at. So the first difference is between indoor and outdoor. So outdoor, indoor. Um, and the difference is also for telemetry data. You won't have probably latitude, longitude, but you will have XYZ. And then what else? If you connect a radio command, This ground station is has the opportunity to let you pilot the drone with a joystick instead of having the radio command of the specific drone, so allowing you for a cheaper communication. Here, if I try to enable it, it pops up an error because I don't actually have the gamepad here, and so I cannot fly the drone with my joypad. And another thing is the fact that if you have the real drone with the camera on and it is connected, by clicking in camera, you would see what the drone sees from the camera. But here I cannot because I don't have the real drone and I don't have the camera. Moving on, in order to start to safely execute missions and other kinds of commands you see here, one important thing is that you have to define fences in order for the drone to not violate those fences. In Drone Lab, you are lucky because you have the net. So, at the worst case, you will end up in the net. But you would like to avoid this event if you can. So, by right-clicking on the map, you will see that there is this menu that allows you to fly the drone when you click where you clicked, to put a waypoint, to clear all point and fences, or to reset buttons. For instance, if some color of the buttons are stuck, you can reset the buttons by clicking here. But for now, what we need is to put a waypoint here. We put another waypoint here, and you see they are connected, so they are part of the same list. We put a waypoint here and another one here. And then we say that we want to create an inclusion fence, which means that the drone has to be inside of the fence. And then you can draw the fence. Here it is, the inclusion fence. And you can also draw, for instance, an exclusion fence, which is a fence in which the drone cannot go in. And for each point of the fence, you can set also the max altitude, which is set to 10 meters, if I remember well, if you do not set any altitude here. And then there is the setup page, since, as you can see from here, if we go into configuration and full parameter list, there is a full list of parameters of the drone. There are too many. And you may need to set up some of these. For instance, the return to launch altitude or geofence enable or parameters of the extended Kalman filter, which is used for localization and so on. But since we have an independent platform, which is our ground station, we want to set parameters directly from here. So here you can, for instance, save drone parameters, read drone parameters. So if you are connected to the drone, you read the parameters um, from the drone, and you can save them in a given file, or you can load the parameters from a file into the drone. Uh, a parameter file. Then, for instance, if you are in indoor and you want to create a fence indoor by obeying to your commands, here you can, I have already created a fence. Here you can select to enable it or not, and this enabling is enabling which is checked by our application, and you can select the activity, the action it must take if the drone violates the fence. Or you can just do another thing, which is the logical solution if you fly outdoor, which is to send, by clicking this button, you send the location to you send the location of the fence to the drone simulation, or if you click it while you have a real drone, you send the points to the drone. So the drone will have a fence which is sent to it, which he will always check automatically for the violation. When you send the fence, um, the drone receives it, but has it doesn't have the fence enabled. So you can see here that if we search for parameters, you will get used to the name of parameters by using the drone. We have fence enable, which is set to 0. You can see, so 0 means disabled. So it will not obey to the fence since they are not enabled. But since I have sent the fence here, this is not a mandatory procedure because the points are already inside the drone, uh, on the real drone. If you have this autopilot and you are in simulation mode, you can verify whether the points were received or not by going into fence and reading waypoints. You can see that these points are exactly the ones I sent from here. And so the points were received. But let's say that now we want to go back to the data here, and I want to enable the fence directly from my application because when I have the drone, I cannot go inside the drone to enable the fences, but I want to set the parameter. So I know that the parameter's name is fence enable, and I want to set its parameter to 1. Be careful, and you will get used to it when you use it, to set the right parameter, since otherwise you will write complete trash inside its parameters and it will not do what you want it to do. So you set the parameter, you click a couple of times, and you will see this is, I repeat, this is not a mandatory procedure, it's just to verify in this case, but when you have the real drone, you will not have this way to verify if it works or not. You can go into configuration, then we remember that the parameter was 0 last time. So if we go to fence enable, we will see that the value is now 1. So the fences are enabled from our application. And I repeat, this in reality works exactly as you see here in the simulation. So once you have settled this, you can either, if the drone has already some pre-made fences inside that were sent to the drone, you can read the existing one by clicking here. I won't do it since now I have already sent my fence and I don't want to create confusion. And here you see outdoor parameters, which are a list of parameters that are specifically thought for when flying outside. So, for instance, it uses the GPS instead of Kalman filter reconstruction. It uses the barometer instead of the laser altimeter, and so on. And indoor parameters set the drone up for specific indoor flights. And here, if you click this, it will push onto the drone the perfect calibrations for laser altimeter and optical flow, which are sensors. So this is a setup window that you use at the beginning, and once you have used it, you close it. Okay, so now that we have explained a little bit of interface, we can go on with basic commands and see the drone in action. So the first thing is that obviously we want to take off, and if we want to set the height of the takeoff, we have to set it here. Um, well, first we read again the existing geofence. We will write again geofence, no, not geofence, fence enable, and we will set it to 1 just to make sure. We close it. Okay, and here we have it. So we set the height of the takeoff and then we click takeoff. And we will see the log that is already in the other um, also in ArduPilot. Here you see the log of everything that is happening to the drone. So it is useful not to go on the other side and see. And also because when you have the real drone, I repeat, you cannot see all these things happening in into ArduPilot. So it is better to see them here. So you see the current is now high since it is using the propellers, and you see that the height is 499, so it has arrived to 5, and we see that there is a notification that the drone is flying. We set OK, and then we can, for instance, click fly here, and it will fly in that specific point. Then what we can do is that, and you will see they are tweaking a bit, but it's because it is difficult to keep the velocity stable when it is at low velocity. Then, for instance, we can select left. There are specific commands for the direction, and we can say move with 3 meters to the left. We select move, and we will see that it goes to its left. So it moves for 3 meters, and when it has finished, you can check also by XYZ, it says finished moving. And another important thing is that you can change the heading. You look here, the heading is changing. So it goes, it looks in another direction, and you can also change the speed. So we set the speed to 9, we move it here, and you will see it is very fast. Let's go back by setting the speed to 1, and you can appreciate how slower it is with respect to the previous one. Then another thing we can do is that we can move to the left by fixing, let's move again to when it has finished. Let's move again to the left, and I will let you appreciate one detail. Okay, it has arrived. So if I click move, it moves by changing the heading, but this is a behavior we may not want. So if we click fix heading and we click move, we will see that it moves on to the left, but the heading stays still, let's say. So this is good. Then we can also plan for, oh, another thing that you can appreciate is that if we click fly here, since it is out of the fence, it will not go. And then another thing we can do is that we can put waypoints. Um, I will also set the altitude for this last point. We say 7 meters, and I click put waypoint, and we can execute a mission. So you click mission, it sends the points to the drone, and so it executes the mission by passing from all these points. And this is the log of what it does. Here you see that, okay, it ends the mission. I have misclicked here because it was not here to set the height, it was here. So if I set, for instance, the first waypoint here with 3 altitude, then I set this to 5, which is the second point, I click here, then I set it to 1 and I click here and I execute the mission, you can see that it stays at 3 altitude for the first point. Then when it goes to the second one, it goes to 5. And then in the end, it goes to 1, since I have set it to be 1. And then it finishes the mission. Another cool thing is that there is this concept of blocking and non-blocking call. When you call a function for the drone to execute in a blocking mode, in order to send other commands to the drone, you have to wait for that specific function to finish. Whereas if you send it as a non-blocking call, you can do other things while the drone is flying. I will make an example. Here I have no, all calls are non-blocking now. So if I click fly here, but in the meantime I want to adjust the heading, you can see that the heading is let's fly here. The heading is adjusted while the drone is flying. Let's do another example. You fly here and I set this to this. You can see that the drone is not pointing the heading where it is going, but it is pointing in another direction. So then here we can select the flight mode. So for instance, we can see that I will make the drone fly slowly here, and while it is flying I will set the mode to brake. So you will see it brakes before reaching the final point, and then if I say fly here, it doesn't fly because it is in brake mode. So I put it to guided again, and you will see that it is guided once again, and then I can fly here again. Yeah. So this is it. I am thinking about other commands. So another important command is the land command, which lands instantly, or for instance, the return to launch. You remember we have launched right about here. And so if I click the return to launch, it goes to the return to launch altitude, which is set as a parameter. You can change in the setup area. So which is 8 meters. It goes to the point, to the home point. And then after it is in the home point, it starts descending in RTL mode. So here it is. This is the first demonstration of all the functionalities of this ground station. It has landed and motors are disarmed. So since we have landed, we can reset all the buttons here. And for instance, we can also change the mode to guided if we want to take off again and so on. And as you can see, the telemetry keeps updating every time. Okay, so now we will see the last part. As you can see, I have already started a drone here. And here I will connect in indoor mode. This time you won't be able to appreciate the difference apart from the features, because not having a real drone with a real optical flow sensor and so on, it is giving problems with the state of the laser altimeter and the state of the optical flow sensor, but it won't give you this problem once you are with a real drone. So in the setup, you would have to press indoor parameters and these optical flow laser altimeter parameters, which are calibrated in a real scenario. But here, what we can do is that we can, for sure, close this session, and we can see by right clicking all the functionalities of the indoor plan, which is add point here, fly here, draw fence inclusion, exclusion, mission, and clear all. These all are handled by an event handler, since this triggers an event handler which is in the main part of the form, since this is an addition to the main form. And we can see, for instance, that we can add point here, here, and one here. And we can draw an inclusion fence. Now we can take off, as we did before, arming motors, the current will rise, and we will see that here the drone starts to take height. So yeah, it is flying. We can fly here. It says where it is moving in the world. And we will see that this will match. Okay. So, okay. So this, you can see that here the drone can go here because of the fact that the fans are not enabled. So we will make it fly here again. And we can have we have this other functionality, so we want to make it go 2 along x, 3 along y, and we want to increase its height by 4. If we click move indoor, it does exactly what we asked it to do, as you can see from here. Okay. Then we can go in the setup, and we can set the mode for fence violation to break, and then we can enable this mode. We close, and we can see now that if we try to fly here, the mode switches to break, and then it is sent back inside the fence automatically, and the mode is restored to guided. So also, if we try again to violate here, break, and then guided here. Then also there are modes for indoor flight with the joystick, that if you keep pushing to go outside, it puts you inside, and the mode is set to break forever until you manually unset it. This is to avoid the effect of pushing, and then when it is to guided again, you can break the fence, and this may lead to dangerous behavior if you continue heading towards the violation of the fence. But I cannot show it since I do not have a joystick. But here we can also plan a mission by adding points here, 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 and we can execute a mission like this. So this is it for what concerns the usage of the usage of the ground station. Now we will have a brief look at the code, which is not that complicated. But first, I want to say that, as you have seen, the ground station can be improved from many points of view. So you go ahead, you choose what points are not working, what points can be done better, and you can do it, since it was practically built in like a month and a half. So it has still many changes to be done. And now we will have a brief look at the code. First, the one of the ground station. It is divided into sections. So if you want to inspect a section, you right click on the section and you have visualize code. Otherwise, it will open the designer, which is not what you want to do. So here, the form one is um, used to initialize all the components of the Windows form. So the picture box, the map, you add the image of the drone, um, the here there are the subscribers to the events from the Cartesian plane control. As I said, you click, you generate an event that is handled here with this function, the map from Google Maps, and so on. And here all the variables needed for the ground station are instantiated. Then we have the part, for instance, related to geofence. So the one that creates fence, checks for violation with an algorithm, um, safety calls for land, for RTL, for the pushback in the brake mode, the one that sees if the point is in the polygon, and so on. Here are some helpers that are useful for the visualization to clear missions and so on. And obviously, I will not explain in detail because you will get into confidence with this once you are in once you are working on it. But one good thing you can do is to get familiar with this is by typing double slash and starting making comments. The copilot suggestion will help you understanding what the line does. Update the altitude of the reference point, for instance, and and so on. So this will be helpful, for instance. Um, so these are the helpers. So I will close without saving because obviously I won't save. Then there is this part which is dedicated to getting the data from the joystick. So there is the device instantiation, then there is the pulling from the joystick, and here it pulls data for all the channels of the joystick with a polling mechanism, and it converts it into commands. Here for some channels, such as the buttons of the joystick, are used to set a flight mode. One is used to take off, and so on. Then here is the part that concerns the setup form. Here you see all the parameters of the parameter list. Then there is the telemetry part, which is to publish messages, uh, to process the log, which was the one you had seen on the right part. Here is to process all the types of telemetry messages um, and put them in the right squares in the form, and so on. Also here you will see you will see, let's say, all the processing of the telemetry messages, because some messages are sent in millimeters, some messages have to be converted from um, latitude, longitude to meters, and so on. So this is all the logic. And here um, user uh, user interface 1 and 2 are the user interfaces for the buttons you see on the form. So the simulation buttons, the connect, the uh, take off click, land click, and they directly say what happens if you click the button. So if you click land, the instance of the drone you have created is sent with the land command, and you change the color for the landing, and so on. So here enable the telemetry, so you start sending and processing the telemetry, and so on. This is both for UI1 and UI2. So here you see outdoor parameters, indoor parameters. So um, if there are errors with outdoor parameters and indoor parameters, you know that you have to check the parameters indoor. You will find it in the code, what is the parameters indoor and so on. Um, and so you inspect the code and you get what happens with the code. Here, for instance, parameters indoor are these ones. Parameters outdoor are these ones. So you see what are the problems and you can handle them. The fact that it is divided into sections helps you understanding where something is going wrong, and it helps having a modular structure. So for instance, the callback part is the one that addresses what kind of callbacks are executed once a command is finished. So unless you want to add a callback here, this part is kind of useless, for instance. Here, the camera WebRTC and WebSocket are the two methods to display the camera, which are done with a Python wrapper, if I do remember correctly, at least for one of the two. Yeah, it executes a script with a wrapper. And so these are dedicated to the camera. So if there is a problem with the camera, you know that you most likely will have to look here. Then there is the Cartesian plane control, which is the one that addresses all the commands and all the things that happen inside the Cartesian plane for indoor flights. And so by looking at the code, also here you can do this, and there is the suggestion for what the line does, or you can use the chatbot to understand. Then another thing that I have to address before closing the overall brief tutorial made by a student for students. So forgive me if I was not that accurate, or if my English is not that good. Is the part related to the drone link library. Also, the drone link library has this is tough in some passages. Uh, it has a modular structure, so that also here you can add, if you want to add some command, you know where to add them, and how the library works. So here you have all these sections that implement commands that, after sourcing the library file, the DLL, you can use. So if we go into drone basic, you see that you have the takeoff command, you have the land command, RTL, which are all the commands that you can use. In fact, they are part of the class drone. They are the drone class methods. And so it is divided into parts. So there is the drone part, which is the first one, in which you create the class drone with the ID, the mode, relative altitude, latitude, heading, and so on. The most primitives, the primitives such as the send message, and the method for sending commands, the connect one, the telemetry request, which is the one that is in charge of actually instantiating all the telemetry requests, since the communication is done with the Mavlink communication protocol. And if you do not instantiate a message for the request of a given part of the telemetry, it won't send you telemetry. So this is for sending all the messages for receiving telemetry of any kind. And here you see, for instance, the telemetry indoor, which is the part related to X, Y, Z, VX, VY, VZ, and so on. So drone telemetry is for telemetry. You know where to look at. So for instance, if you want to add another telemetry message, you put another um, telemetry request inside the telemetry request list. You had another function for the kind of telemetry you want. So you receive the message and you take the data, and then you process also the data. So latitude, longitude, and so on. Um, or for instance, you have the drone movement part, which is the one move left, right, and so on. So it is all divided into sections. I will not explain one by one. And by updating here, by recompiling, retaking the file into the other ground station part and creating a reference to that, you will be able to use your new parameters, so let's say your new functions, um, which is kind of useful. You can implement new things into the ground station. So I think this is it for what concerns the code organization, and this is it for the overall tutorial.